We are going to finish up section 6.1 by trying to find the area of an oblique triangle when you're given two sides and the angle that lies between them. Okay, so here you can see I've started to draw a triangle, and let's say you know the length of side C and side B, and you know the measure of angle A. As you can see, you're given two sides and the angle that's between them, so you're looking at the case of side angle side in this case. So, you all should be familiar with this formula from geometry. Area of a triangle is equal to 1/2 base times height. The problem is I do not know the height of this triangle yet. So what I'm going to do is I'm going to go ahead and drop an altitude here from angle B down to side B. That is your height. I'm also going to draw in a couple other segments here so you can see this a little bit better. When I drop in that altitude or that height, what I've done is I've formed two right triangles. I've got the dark red one here that I've just put into the left. I also have the triangle that's into the right, but I'm going to be dealing with the triangle that's on the left since you know angle A and side C. Here's my height. To use this formula, I need to know what this value is. Seeing this red triangle over here to the left being a right triangle, I can use my trig ratios to find the height. Given angle A, looking for the height, knowing what C is, I can use the sine to write the equation. The sine of angle A would equal the height over side C. Now if I want to try to solve that for H, I need to get rid of the C by multiplying both sides by C. And that would cancel on the right, and I'd end up with the height is equal to C times the sine of A. Now that I've solved for H, I'm going to go back to my formula you should be familiar with and replace the height in that formula with what we just found the height to be. So, in doing so, I end up with the equation area is equal to 1/2 B times C times the sine of A. And that's the formula we are now going to use when you're given two sides and the included angle. Now these sides may change and the angle may change, but as long as you have two sides and the angle that's between them, you can use this formula. So in other words, this could be A, this could be side B, then this would be angle C over here. So it doesn't matter which two sides as long as this is the angle between those two sides. So let's look at an example. I want to find the area of the triangle with the given information. I've got little a is 90 meters, little b is 52 meters, and angle C is 102 degrees. So again, my formula, the area of a triangle will equal 1/2 times one of the sides that I'm given, which is A, times another side that's given, which in this case is B, times the sine of the angle that's between them, which in this case is angle C. So filling those in, I'd have area is equal to 1/2 times 90 times 52 times the sine of 102 degrees. When I do all that multiplication, the area ends up being equal to approximately 2,288.87. And that finishes section 6.1.